Hello, welcome. In this class, we try to solve some numerical problem based on shear force and bending moment diagram. First question, draw the shear force and bending moment diagram for the beam which is loaded as shown in figure. Determine the points of contraflexure within the span AB. First, we need to draw the shear force and bending moment diagram, then find out the point of contraflexure. It is a overhanging beam of span support to support length is 8 meter and right side overhang portion is 2 meter length and left side is 3 meter length, and point load are shown in this given figure: 10 kilonewton, 20 kilonewton and 8 kilonewton. Now let me find out first reaction of those support A and support B. Reaction at support A say RA and reaction at support B say reaction RB. I have choose a point. This is point C and this is point D and this is point A. Now taking moment about any point, any of support point is 0. Say let me taking moment about taking moment about at a point A, either A or B. Let me choose the A. Point A is 0. So that means summation of moment about point A equals to 0. Now we need to find out the moment about point A by the all force and find out the reaction at point B. Now moment at point A by this force is 8 into perpendicular distance 3 meter, 8 into 3, which is anti-clockwise. Say this is negative, we can consider it negative, anti-clockwise, and by this force 20 kilonewton it will be clockwise. So force into perpendicular distance is 5 meter, so plus 20 kilonewton force into perpendicular distance 5 meter. And now reaction force RB, which is upward direction, that means force moment about point A will be anti-clockwise, that means moment will be minus reaction force RB into perpendicular distance from support to support is 8 meter into 8, and by this load 10 kilonewton load, it will also positive moment, that means it is anti-clockwise, that means plus 10 kilonewton into perpendicular distance from here to here is 2 plus 8, that means 10, 2 plus 8 meter perpendicular distance. So this is the moment about point A, so it is equals to 0. Now find out the reaction RB. So reaction RB, that is 8 RB is equals to 8 RB is equals to what? 20 into 5, 100, plus 10 into 10, it is also 100, minus 8 into 3, 24. So RB is equals to 200 minus 24, 176 divided by 8, which is equals to 22 kilonewton. 22 kilonewton. Now find out the reaction RA. So we know reaction RA plus reaction RB is equals to total load on the beam. Total load acting on the beam, that is 8 plus 20 plus 10 kilonewton. 8 plus 20 plus 10, which is equals to 38 kilonewton. So reaction RA is equals to 38 minus RB. RB equals to what? RB equals to 22. 22. This is equals to 16 kilonewton. 16 kilonewton. Now find out the shear force and draw the shear force diagram. Let me draw again the beam. The support reaction RA is equals to 16 kilonewton, and reaction RB is equals to 22 kilonewton. We have find out, we already find it, and 20 kilonewton at the on the beam in between support, 20 kilonewton. This is the distance from the left support is 5 meter, and at the right side, right hand overhang portion free end is 10 kilonewton. The overhang portion, length of the overhang portion is 2 meter, and left side 8 kilonewton load, and length of the overhang portion is 3 meter. This point A, point B, point C, point D, point E. Now shear force at point E. Shear force. Find out the shear force. Shear force at point A, point E. Sorry, shear force at point E. Shear force at point E. F equals to negative minus 8 kilonewton load. Shear force means unbalanced algebraic sum of the total unbalanced vertical force. Vertical force at that point is downward direction, that means negative. It is the left side portion. In case of right side portion, it will be positive. So at the left side portion, the shear force at point E is minus 8 kilonewton. Now find out the shear force at point A. Shear force at point A just to left means shear force at point E, that is minus 8 kilonewton, and shear force at point A just to right will be shear force at point A just to left, shear force at point A just to left plus upward direction reaction force, that is 16 kilonewton, plus 16, that is minus 8 plus 16, which is equals to 8 kilonewton. Now find out the shear force at point C. shear force at point C will be, here the two shear force, one is just to left and other is just to right to C. Just left to C, shear force just left to C is equals to shear force at point just A just to right, shear force at point A just to right, that is equals to 8 kilonewton, and shear force at point C just to right will be shear force at point C just to left plus, minus, this is downward direction force, downward force, so it will be minus 20 kilonewton, 20 kilonewton, which is equals to C just to left is 8 minus 20, it will be 12 kilonewton, minus 12 kilonewton. Now find out the shear force at point B. Shear force at point B is equals to, at point B having two shear force, just left to the B and just right to the B, left side to the B and just right side to the B. Shear force at point B just to the left side, it will be shear force at point C just to right side, which is equals to minus 12 kilonewton, we already defined it, and shear force at point B just to right, it will be shear force at point B just to left, plus which is upward direction force, it will be plus 22 kilonewton, 22 kilonewton, it will be minus 12 plus 22, it will be 10 kilonewton. And shear force, last one is shear force at point D, it will be load at point D, it will be 10 kilonewton. Now draw the shear force diagram. Now let me draw the shear force diagram. This is the beam. At point E, shear force is minus 8 kilonewton. This is the 8 kilonewton. At point A, having two shear force, just to left is minus 8 kilonewton and just to right is plus 8 kilonewton. Total 60 kilonewton at reaction force. That means shear force will be divided into minus 8 and plus 8. It will be balanced. The shear force at point A is minus 8 kilonewton, this is constant value, and plus just to right is plus 8 kilonewton. Now shear force at point C, just to left is 8 kilonewton, that is point C. This is point C, just to left is 8 kilonewton, and 8 kilonewton, and just to right is minus 12 kilonewton. It will be down minus 12 kilonewton. At point B, shear force is minus 12 kilonewton just to left. This is point B, minus 12 kilonewton just to left, and just to right is 10 kilonewton. And shear force at point D is also 10 kilonewton. This is a shear force diagram for this beam. It is negative shear force, negative, it is positive, it is also negative, and it is also positive. This is shear force diagram. Now put the value shear force at point E. Just to, at point E is -8, it is -8 kilonewton, and shear force at point E just to left is -8 kilonewton, and just to right is +8 kilonewton, and shear force at point C just to left is 8 kilonewton, and just to right -12 kilonewton, and point B just to left is -12 kilonewton, and just to right is +10 kilonewton, and shear force at point D it is 10 kilonewton plus. The shear force diagram. Now find out the bending moment and draw the bending moment diagram. Let me draw the beam. This reaction force 16 kilonewton at A, reaction force at B is 22 kilonewton, and right side overhang free end portion load is 10 kilonewton, and left side portion free end load is 8 kilonewton, and at point C load is 20 kilonewton. This 5 meter, it is 2 meter, it is 3 meter, and total center support to support is 8 meter. Now find out the bending moment. It is very simple. Bending moment. Now bending moment at point A, that means free end always bending moment is 0. That means free end at point E, D, A, B. Free end bending moment at free end E is equals to always 0. Now bending moment at point A, what will be the bending moment at point A? Only this force. That means it is anti-clockwise. For the left side portion, anti-clockwise means negative bending moment. So bending moment at point A will be negative. That negative, it will be force is 8 kilonewton into perpendicular distance is 3 meter into 3 meter, which is equals to 20 minus 24 kilonewton meter. Now find out the bending moment at point C. Bending moment at point C, it will be by this force 8 kilonewton force into perpendicular distance is 3 plus 5, which is anti-clockwise. Anti-clockwise, that means negative, minus 8 into perpendicular distance 3 plus 5, which is anti-clockwise. This is anti-clockwise movement, that means negative, and by this force, reaction force, it will be clockwise. So plus 16 kilonewton reaction force into perpendicular distance is 5. Minus 66 plus 5 into 16, it's 80, which is equals to what? It is equals to 14 kilonewton meter. Linear. It is a linear equation, form of linear equation. Now find out the moment about point B. Moment about point B. we can calculate from right side section. For the right side section, clockwise means negative bending moment, and for the left side section, anti-clockwise means negative bending moment. So it will be negative at point B. It also negative at point B. So minus force 10 kilonewton, 10 kilonewton force into perpendicular distance is 2 into 2 equals to minus 20 kilonewton meter. Now check it. How can I check? We'll also check it from the left side portion. Let me again check. Let me check. Bending moment at point B by this load, this reaction force, and also this load. It should be minus 20 kilonewton. To find out bending moment at point B for check, 8 kilonewton into perpendicular distance 3 plus total length support to support is 8. That means 8 plus 3 into 8. It will be minus anti-clockwise moment minus 8 into perpendicular distance 3 plus 5, 3 plus 8, 3 plus 8. And for this reaction force, it will be positive clockwise moment. So 16 into total perpendicular distance is 8. So plus 16 into total perpendicular distance is 8. For this load 20 kilonewton, this load, it will be anti-clockwise. It is anti-clockwise, so it will be bending moment will be negative. So perpendicular distance is 3 meter. 8 minus 5, it is 3 meter. It is 3 meter. 3 meter. So minus 20 anti-clockwise moment. It will obviously minus. So 20 into perpendicular distance is 3. Now it will always definitely it will be minus 20 kilonewton per meter. Let me calculate. 8 plus 3, 11. 11 into 8, that is minus 88, plus 8 into 16, 8 is a 16, this plus 128 minus 3 into 20, it is 60. Now calculate it. Definitely it will be minus 20. 88 minus 88 plus 128 minus 60. It is minus 20 kilonewton meter. So our bending moment, our calculation is perfect. Now draw the bending moment. Now we can draw the bending moment. Now one thing is the bending moment at point D. What will be the bending moment at point D? Always 0. It is free end. So here I am write by the using black pen. The bending moment at point D, it will always 0. You can also check it from this side. It will definitely 0. Now draw the bending moment diagram. This is the beam. Bending moment at point E is 0. Bending moment at point A is minus what? Minus 24 kilonewton. Minus 24 kilonewton. Minus 24 kilonewton. It is linear. And bending moment at point C, is 14 kilonewton. 14 kilonewton. So positive value, it is point C. The bending moment is 14 kilonewton here. Bending moment at point B, it is point B. Bending moment at point B is what? Bending moment at point B is minus 20 kilonewton. So minus 20 kilonewton is here. So draw the linear diagram. And bending moment at point D is 0. This is a positive bending moment. Sorry, this is negative bending moment. This is positive. And this is also negative. Now put the value. Bending moment at point is point E. Bending moment is 0. Moment equals to is 0. Bending moment at point, this is point A. Support point bending moment is 6. Bending moment is what? 24. 24 minus kilonewton meter. Bending moment at point C. Bending moment, this is point C. Bending moment at point C is equals to plus 14 kilonewton meter. And bending moment at point B is, bending moment at point B is 20 kilonewton minus this point B minus 20 kilonewton meter. And bending moment at point D, this is point D, bending moment at point D is equals to, moment at point D is equals to 0. Now also find out the question is says, asked me the also determine the point of contraflexure within the span AB. Within the span AB, find out the point of contraflexure. What is point of contraflexure? Where the bending moment, it's changing sign from positive to negative, from negative to positive and positive to negative. These two are point of contraflexure. These two are point of contraflexure. It is one point of contraflexure and this is also point of contraflexure. Now find out the distance from A and from B. Find out those distance. Let me choose a section. Let me choose a section. It is, let me choose a section, cut a section XX and it is X from point A. At that point bending moment is 0, means point of contraflexure means bending moment is 0 at point XX. Now find out the moment about this point. What will be the moment about this point? 8 into perpendicular distance 3 plus x, 8 into perpendicular distance 3 plus x, this is minus anti-clockwise, and 16 kilonewton load, it will be positive, so 16 into x, it is equals to 0. So here I am writing the next phase. Bending moment about xx is equals to 0. So at xx point bending moment is equals to 8 into perpendicular distance, what? 8 into perpendicular distance 3 plus 3 into perpendicular distance 8 into 3 plus x, 3 plus x, which is negative because it is anti-clockwise movement. By the 16 kilonewton reaction force, it will be positive because it is clockwise movement. So 16 into x plus 16 into x, it is 0. It is is it a bending moment at point xx? Yes, it is a bending moment at point xx, which is equals to 0. So we can find out the value of x. Now let me find out the value of x. This is 16x minus 8x equals to 24. Now 8x equals to 24. So x equals to 24 divided by 8, which is equals to 3 meter. So, from point A, point of contraflexure, from the support A, point of contraflexure, distance point of a contraflexure is 3 meter. Now, find out the point of contraflexure from B, means at this point, this is the also point of contraflexure. Find out the distance from B. Let me choose a section at the bending moment. Say section is YY. Choose a section is YY and distance Y point from B. Sorry, Y from B. Now find out the moment about point YY. Moment about point YY is equals to what? Is equals to, by this force 10 kilonewton, 10 into, by this force 10 kilonewton into 10 into 2 plus y, 2 plus y, which is positive, 2 plus y into 2 plus y, and by this reaction force it is clockwise, and by this reaction force it will be anti-clockwise, that means negative. Reaction force is 22 kilonewton. 22 kilonewton means 22 into perpendicular distance is y, minus 22 into perpendicular distance y, which is equals to 0, because point of contraflexure, bending moment is 0. Now find out the value of y. It will be 10y minus 10y minus 22y is equals to 10 into 2, 22, minus 22, minus 12y is equals to minus 22. So, y is equals to 22 divided by 12. It is 1.83 meter. Now let me explain. Let me some brief review for point of contraflexure. This is a point of contraflexure. Some brief review for point of contraflexure. Let me draw again the beam. Just review. Reaction force 16, and here reaction force is 22 kilonewton, and point load here is 20 kilonewton, and it is 10 kilonewton. It is 8 kilonewton. Point A, let me here the point of contraflexure xx and distance x. So moment about this point is equals to 0. About this point is equals to 0. So moment about this point for this 8 kilonewton load, 8 into 3, this distance is 3 meter, 3 plus x perpendicular distance, and 16 into x, which is equals to 0, and we find it x equals to 3 meter. Now choose a section, cut a section YY, distance y from point B, this is point B, y, and by this 10 kilonewton load, moment is 10 into 2 meter, this is 2 meter, 2 meter into 2 meter plus y, 2 plus y, 10 into 2 plus y, and by this reaction force, anti-clockwise moment, it is negative 22 into perpendicular distance y, and we have find it that y equals to 1.8 meter. This is the point of contraflexure. I hope you understand. There's no problem at all. Thank you.